In this tutorial, I want to talk about semaphores. We will understand what semaphores are and when and where you use them. Semaphores are constructs which are, I kind of find them very similar to locks conceptually, but with a slight twist, with a slight difference. Semaphores allow permit-based access. It's basically allowing a few number of threads at most to be able to access a resource at any time. You can think of semaphores as like passes or permits to access critical resource. And the way to contrast it with locks are, if you use a lock, you're basically looking at just one thread accessing a critical section at any point of time, one thread executing in a critical section at any point of time. Whereas with semaphores, you have a limited number. It's not necessarily one. You can say, okay, at most only 3 threads can run a piece of code at any point of time, right? So that is what you use semaphores for. So in semaphores, you can say, okay, I want to allow at most 3 threads or at most 4 threads. And the first 4 threads that accesses that critical section, it's going to let go. The JVM is going to allow it. And then the 5th thread that tries to access that critical section has to wait until one of those threads, which are already in, releases. All right. So it's kind of like a lock, but instead of just one thread going at a time, you have a controlled number of threads going at a time. And typically you use semaphores for managing limited resources. So for example, you want to have, you have threads which open files, and you want to limit the number of concurrently open files on a system. You use semaphores for that and say, okay, I want at most only 5 file handlers open. Well, you can use that by using a semaphore to block, to protect the piece of code where file handlers are open. Let's say you have a semaphore which allows 5 threads at a time, where you can kind of rest assured that only 5 file handlers are open at a time. So when you have this kind of a limited resource and you have a concurrent environment, and you don't want to like make it one only at a time, but at the same time you want to have an upper bound, an upper limit for how many concurrent usages of a certain resource or a certain critical section is. Well, you can use semaphores for that. I'm going to demonstrate semaphores by switching to the IDE. I have this prime number with semaphores, which is literally a copy of the prime number example with starting a new thread. This is no different from what we first started out with. We're basically getting a user input for n and then creating a runnable to calculate the value of the nth prime number and then starting a new thread, right? There's no limit to how many threads can be started. Now notice here that this is not a use case for locks. Okay, I don't have to lock this because each one of them is running it separately and there is no shared resource here, right? I don't need synchronization. But suppose I want to say at most only like 3 calculations can happen at a time. Okay, you want to limit that so that the user doesn't go crazy and enter like a bunch of big numbers and then keep spawning threads. Well, for that, you can either use a thread pool using the executor service, or you can use a semaphore and limit the number of executions of the run method, right? So in order to create a semaphore, just like creating a lock, you create a new semaphore object, and you do that by using semaphore equals new semaphore. And now this semaphore takes in a constructor argument, which is how many passes you want to allow at a time, right? So let's say I say 3. And this basically means that whatever I'm protecting with the semaphore, only 3 threads can access that at the same time, right? And anything more than that will have to wait for one of those 3 to release. Okay, so I have created a new semaphore. And now what I need to do is first, just like you acquire a lock, I can say semaphore dot acquire. Okay, what this does is it tries to acquire one of the passes. Lock is just one, semaphore is multiple. Limited, but multiple. So it basically tries to acquire one of these 3 passes in this line, okay? And if it acquires it, then it continues executing. If there are no passes available here, maybe 3 have already gone in and then this is the 4th one, well, this is a blocking operation. It'll wait for one of those 3 which have already gone to release the semaphore, release the pass before this thing goes in. So this is gonna block at that point, all right? And at the end, I need to make sure I release. So I do a semaphore.release. Now this acquire, since it has a blocking operation and since it can wait, you know what's happening. This throws an interrupted exception. Remember, anything that waits will throw an interrupted exception because it can potentially get interrupted. So what I'm going to do is I'm going to surround this in a try catch block so that I can catch the interrupted exception. And also what I'm going to do is I'm going to use this. Let me first put the catch block here. Interrupted exception E, and then I'll just do a sysout interrupted while acquiring. Okay, and I'm going to use this as an opportunity to put a finally over here, and I'm going to do a semaphore.release in the finally block, which I really should be doing because I want to make sure that the semaphore does get released. Just like with the lock, right? We follow the same pattern with the lock. We wanted to make sure that the lock gets released no matter what, whether this thing completes successfully or not. So I have to use a finally block to have that guarantee for the semaphore as well. Okay, so this is what I do. And now what I'm going to do is I'm going to have a sysout over here. I'm going to say now calculating for n. Okay, so this is basically going to print when the semaphore is acquired and it is busy calculating. So this allows me to differentiate between the wait when the semaphore is trying to be acquired and the natural wait for calculating the prime number, which I anticipate for large numbers. Now, if I were to run this thing, you notice that I can, at most, run 3 big numbers at a time. Prime number calculation for 3 big numbers at a time. The 4th big number that I enter, it is not going to allow it. Okay, so if I enter small numbers, it's going to render it. It's going to calculate and show the result. No problem there. But let's say I enter a big number. Okay, it's calculating. Another big number. It's calculating. Another big number. It's calculating. And now, if I enter a small number, well, you notice here, it doesn't calculate. It doesn't say now calculating for 3. Why? Because these 3 big numbers have taken the 3 acquires for the 3 semaphores, and the small one is now blocked over here. It's stuck here. It's trying to acquire a semaphore. It needs to wait for one of these big guys to finish, and only then it can start running this. Okay, so it's queued up and it is waiting. Okay, if I were to enter another one, that is going to be waiting as well. It needs to finish this first one, at least the first one, or whatever is the quickest one, right? If I've entered a smaller number, it might end up doing the later one sooner. But when whatever is done, it is going to complete this, and then it is going to release, and only then my next value is going to get picked up. Okay. The thing though is it may not always pick up the next value. You know that now there are 2 threads which are waiting. And there's no guarantee as to which one gets picked up. Okay, you would think it should be ideally be fair. This one happened first. This one's waiting for the longer period of time than this guy, right? So this should happen first. Well, not exactly. It may not pick this one. It basically picks whatever other one from whatever is waiting. So in order to enforce that it does in the right order, you have this other argument to the semaphore constructor. It's an overloaded constructor, which is a Boolean. It's a Boolean for indicating fairness. Okay, so you see here there is a constructor which takes the number of permits, and then also a Boolean fair. Is this a fair semaphore or not? If you say this is, I want it to be a fair semaphore, then this semaphore will guarantee first in, first out granting of permits under contention. So now what will happen is, if I make it as fair, then let's say these 3 big calculations are done and there is a free semaphore permit available, then it is going to pick among the waiting threads, which are these 2, it is going to pick the one that waited the longest, which is going to be the first one. Okay, so that's the fairness guarantee. Now, there are a couple of other things that you can do with the semaphore. So for example, in the semaphore.acquire, instead of semaphore.acquire, you can do semaphore.acquire uninterruptedly. Okay, so this is going to not throw the interrupted exception, and it's basically going to acquire the semaphore only if the thread hasn't been interrupted. All right, we have seen a similar syntax, a similar method like this in the lock, I believe, but there are a bunch of other places where you can do something like this, like do something uninterruptedly. So it's basically going to check if that thread was interrupted before doing anything. Another thing you should know is that you can actually acquire and release multiple permits. Okay, so let's say I want to acquire 2 permits each time. Why would I want to do it? Well, maybe this is kind of like this particular piece of code kind of orchestrates and sends off 2 other threads. Well, you have ability to take more than 1 pass. Okay, and right now it's 2 passes. You can take more than 1 pass, or if you skip this argument, it is basically just taking 1 permit. So these are the available features of a semaphore. Again, a semaphore is something that you would use to not to synchronize stuff. Again, there is no guarantee that there's only one thread running at the same time unless you use a semaphore of one. These are multiple threads, and using a semaphore is not going to guarantee that you won't have concurrency issues. You could still have race conditions and all that stuff. But what you are doing here is providing controlled access, all right? You're setting limits, and it's not just about one at a time, okay? Slightly different use case, but the APIs are kind of similar to locks, so that makes it a bit easier to understand. So these are semaphores.